Okay, so chapter now is on electrochemistry. So electrochemistry. Well, before we get into there, we need to do a little bit of reviewing because we need to balance oxidation and reduction reactions. So remember, oxidation is loss of electrons, reduction is gaining electrons, and we had in the previous semester rules for assigning oxidation states. And here are the rules right here. And then how to balance an oxidation reduction reaction. First thing you do is assign oxidation states. Then you write and balance the half reactions for getting the electrons. You balance the oxygens with waters, the H's with H pluses, and then if it's in a basic solution, then you're done for acidic. If you are in a basic solution, you neutralize with hydroxide. So I'll do examples for all of them. So let's do this here. So balance the redox equation here, and at first glance, it looks like it's done. Like, oh, I don't have to balance it, it's already done. Well, actually, if you look here, if you track the electrons, you have aluminum goes to aluminum plus 3 electrons. So 3 electrons are generated by this. And then copper plus 2 electrons yields copper metal. So you have these two reactions here where you are generating 3 electrons in one equation and you are consuming 2 in the other. And then for me, I always have to look at the lowest common number, lowest common denominator of 3 and 2. The lowest common number of 3 and 2 is 6. So 3 and 2 are both prime numbers. You have to multiply them together. So you have then this case where you have to multiply the top equation by 2 and the bottom equation by 3 to both generate and consume 6 electrons. So that is actually the way you balance this equation. So that's a simple one. That's a simple one where you just have electrons and metals, so nothing else. So if you want to try it for this one here, give it a whirl. So hydrogen plus chromium metal makes hydrogen gas, and chromium plus 3. I'll give you a hint here. Here are the half reactions, and then you have and you balance then, so you can see you have 2 hydrogen atoms, or two hydrogen ions plus 2 electrons makes hydrogen gas. So again, you have 3 and 2, so the lowest common denominator here is 6. So you got to multiply the top equation by 2 and the bottom equation by 3. And so then they'll give you 6, 2, 3, 2. That's how you solve that one. Okay? All right, so now we're going to do things that have a little more complicated. So I'll do it step by step. Balance the following equation in a acidic solution. So we have iron plus 2 plus permanganate makes iron plus 3 and manganese plus 2. And it's easy for the monatomic ions, but you have to follow the electrons. It turns out that the oxidation state is plus 7 in manganese. So that means the half reaction is MnO4 minus plus 5 electrons forms Mn plus 2, and iron plus 2 goes to iron plus 3, and it pops off an electron. So remember the oxidation state, the more positive oxidation state means fewer electrons. So permanganate needs 5 electrons to go from a plus 7 state to a plus 2. And when iron goes from a plus 2 to a plus 3, it loses an electron. So if you can see here, the way you get around this, you have the common number between 5 and 1. You multiply it by 5. So that means here is the state there. Now, let me copy this. It's nice to be able to copy it so you can see it step by step. So now, the next thing we're going to do, we balance the oxygens biting waters. So we have 4 oxygens over here, so we need 4 waters over there. Okay? So we got 4 waters, and now we have So 4 times 2 are 8 hydrogens there, so we need 8 hydrogens there. And now because of this, it's balanced. So now we've balanced this equation. So we balanced with the oxygens biting waters, and then we balance the hydrogens on the other side. So now we have everything balanced. We have 5 electrons being generated, 5 electrons being transferred. We have 4 oxygens on the left, 4 oxygens on the right, 8 hydrogens on the left, 8 hydrogens on the right. So we have everything balanced. So this is how we do that one. So now let's look at it here. And well, the textbook does it a slightly different way. The textbook, the way the textbook does it is it balances the waters and the hydrogens here. So the way the textbook would do it then, it will write the half reactions, balance the electrons, and then it goes ahead and then adds 4 waters and then 8 hydrogens that way, and then adds this together, and then they add these together. So that's the way the textbook does it. So if you want to do it that way, that's fine too. It just depends on which way you want to do it. So actually, I get excited when I do these. Are fun. So all right, let's see if we can figure this one out. Think about it. Pause it for a second while I come up with a solution, and I'm starting now. Right. So we already showed this MnO4 plus 5 electrons goes to Mn plus 2. And then aluminum going to aluminum plus 3 electrons. And so because of this common denominator of 15, 3, and 5, both prime numbers, so we need 3, 5, 3, 5. And there are 12 hydrogen or oxygens, so we need 12 waters over there. And then we need 24 hydrogens on this side to balance it. So that's the way you balance it. So fun. All right. Yeah, actually, I do think it's fun. So if you think of this as math and hard work, it's gonna drive you insane. Think of it like puzzles. These are puzzles to be solved. So solve puzzles. I like solving puzzles. Okay, so balance the following equation occurring in basic solution. So same idea. So remember, permanganate, this was plus 7, as we learned before, and now we're plus 4. So the half reactions for this equation, it is MnO4 minus plus 3 electrons yields MnO2. And then we have, for the iodine, you have 2I minus goes to I2 plus 2 electrons. So those are the half reactions. Of course, you have 3 and 2 again, so the overall is 6, so 2 and 3. So you have to do 3, 2, wait, oh, sorry. It's going to be 6. 6, 2, 3, 2, like that. So I'm going to get rid of the, well, I'll go ahead and copy this and I'll. So let me show you step by step how to solve this. And the next step is we solve it in the acid. So this run here, 2 times 4, we have 8 oxygens, and 2 times 2 over here, we have 4 oxygens. So we need 4 waters here. So 4 waters, which means we need 8 hydrogens over here. So now we've balanced it in an acid. So we've balanced this in acid. And now the next step is we need to neutralize. So this is an acid, but we have base here. So what we need to do is we need to add both sides plus 8OH minus. So we're going to add 8OH minus there, and so when we add the 8OH minus, we get 8 H2Os plus 4 H2Os on this side, plus 8 OH minus on that side. Now, where are we at? We need to do minus 4 waters on both sides to balance it out. And wait, I should just paste it. So subtracting 4 waters on both sides, we get 4 H2Os plus 6 of that, and then plus 8 OH minus is there. So if you want to check to see the number of electrons, right? So we are transferring 6 electrons. Oh, I forgot to didn't get rid of this when I pasted it. We are generating 6 electrons and are consuming 6 electrons. For hydrogens, we have 8 hydrogens on both sides. For oxygens, so we have 4 from the waters, so we have 12 oxygens on the left, and then we have 4 plus 8, 12 oxygens on the right. So we've balanced everything out, and then this is it in basic solution. So I don't like the basic solution as much. I think the acid's more fun. But that's how you do a basic solution. But once you get good at these, they can be kind of fun. So I'm going to do these really fast. So let's look at A. So if you want to see a few more examples. So looking at A, our half reactions. So nitrogen minus 1, the nitrogen is, so wait a second, minus 1 equals nitrogen plus 2 times minus 2. That means nitrogen is plus 3, and nitrogen here is plus 2. So that means our half reactions are NO2 plus electron makes NO, and 2I minus goes to I2 plus 2 electrons. Plus 2 electrons. So we need to multiply the top equation by 2. So we put 2's here. And then we got to balance the oxygens. So we have 4 oxygens on the left and 2 on the right. So we need 2 waters. And then we need 4 H pluses there. Plus there. So that's how you do the first one. The second one here, B, I'll do in red. Actually, I'll just... So ClO4, so ClO4 minus, so minus 1 is chlorine plus 4 times minus 2. That means that chlorine is equal to plus 7. And for ClO3 minus 1 is chlorine plus 3 times minus 2. Chlorine is plus 5. So that means our half reactions are going to be, that's a G, ClO4 minus plus 2 electrons makes ClO3 minus. And then we have 2Cl. Oh, and I guess I forgot I should need a 2 here. I forgot about that. 4H plus that. Okay. 2Cl minus goes to Cl2 plus 2 electrons. And they're the same. So we just need a 2 here. And that's balanced in regards to that. But we have an extra oxygen, so we need a water over here, and we need 2 H pluses over there to have that equal to each other. So see how much fun this is? See, time flies when you're having fun. And I'll change colors to green. So nitrate, it's going to be plus 5. So C minus 1 is equal to nitrogen plus 3 times minus 2 for oxygen. 5 is nitrogen. And then nitrogen here is going to be plus 2. So that means that our half equations are NO3 minus plus 3 electrons makes nitrogen monoxide. And also 10 plus 2 goes to 10 plus 4 plus 2 electrons. So we need to multiply this one, oh wait, not by, so 3 and 2 is 6, so top one by 2, bottom one by 3. So that means that This one is 2, 3, 3, 2. And there are 6 oxygens on the right, 2 on the left, so we need a lot of 4 waters there, and that means we need 8 hydrogens there. And we are done, right? So there you go. So once you get a hang of these, they're pretty easy, and they're actually kind of fun. And if you think of them like puzzles, remember, puzzles, not crazy math. If you think of it like crazy, unknowing, confusing math, then you're just going to hate everything to do about this all the time. So when you realize that math is a tool and you're the master of the tool, you'll be fine. I am the master of the tool. Say that just as your mantra. So keep that going. And next time we'll go into some more of the electrochemistry. This is just more a tutorial to figure out how to balance oxidation reduction equations.